Hello and welcome back to Steve and Data. Before starting this video, I should say I know that I have not given many of the data science buzzwords definitions like business intelligence or artificial intelligence yet, but don't worry, I will talk about them soon. At this time, I prefer to talk about statistics. I know that it may seem boring and in some cases intimidating, but like it or not, you should face it, because in data science, statistics is at the core of sophisticated machine learning algorithms, capturing and translating data patterns into actionable evidence. Data scientists use statistics to gather, review, analyze, and draw conclusions from data, as well as apply quantified mathematical models to appropriate variables. But don't get afraid, because I promise you will have fun during learning statistics, because unlike your teachers that just teach you the formulas in statistics, I will teach you how to derive information with the help of it in real-world problems, and you will see how wonderful statistics is. Okay, enough talking. Let's continue to learn statistics in order to add another powerful tool to our data science toolbox. In this video, I'm not going to dive straight into statistics formulas and definitions. Instead, I want to explain the role of statistics in our real-world problems to make you enthusiastic about this field. So, let's see what we can improve in our world with the help of statistics. First of all, we should know that statistics is a science that helps us make decisions and draw conclusions in the presence of variability. To give you an example, you can think of civil engineers. Civil engineers working in the transportation field are concerned about the capacity of regional highway systems. A typical problem related to transportation would involve data regarding these specific systems' number of non-work or home-based trips, the number of persons per household, and the number of vehicles per household. The objective would be to produce a trip generation model relating trips to the number of persons per household and the number of vehicles per household. A statistical technique called regression analysis can be used to construct this model. A trip generation model is an important tool for transportation systems planning. Regression methods are among the most widely used statistical techniques in engineering. To give another example, you can think of a hospital emergency department. The hospital emergency department, or ED, is an important part of the healthcare delivery system. The process by which patients arrive at the emergency department is highly variable and can depend on the hour of the day and the day of the week, as well as on long-term cyclical variations. The service process is also highly variable, depending on the types of the services that the patients require, the number of patients in the emergency department, and how the emergency department is staffed and organized. An emergency department's capacity is also limited. Consequently, some patients experience long waiting times. But you should ask, how long do patients wait on average? This is an important question for healthcare providers. If waiting times become excessive, some patients will leave without receiving treatment. Patients who leave without receiving treatment do not have their medical concerns addressed and are at risk for further problems and complications. Therefore, another important question is, what proportion of patients leave without receiving treatment from the emergency department? These questions can be solved by employing probability models to describe the emergency department, and from these models, very precise estimates of waiting times and the number of patients who leave without receiving treatment can be obtained. But after all these examples, you may ask, those examples were about the role of statistics in different fields like engineering. We have not known what statistics has to do with data science yet. Yes, you're right, but be patient. I'm about to explain the role of statistics in data science as well. To put it in simple words, statistics is the basic use of mathematics in formulating a technical analysis of data. It is used to process complex problems in the real world so that data scientists and analysts can look for meaningful trends and changes in data. Different statistical techniques Functions, principles, and algorithms work together to provide us with an ideal statistical model. When the data is big and unorganized, statistics play a powerful role in that situation. When a company uses statistics to find insights, it makes the tedious task look minimalist and easy in front of the big and buffer information that was provided earlier. Statistics eradicates the unwanted information and catalogs the useful data in an effortless way, making the humongous task of organizing inputs seem so easy and serene. Some ways in which statistics helps in data science are prediction and classification. Statistics help in prediction and classification of data, thus we can make use of it to predict the future. Statistics helps to create probability distribution and estimation. Probability distribution and estimation are crucial in understanding the basics of machine learning and algorithms like logistic regression. Cross-validation and LOOCV techniques are also inherently statistical tools that have been brought into the machine learning and data analytics world for inference-based research, as well as split and hypothesis testing. Statistics helps you in pattern detection and grouping. Statistics helps in picking out the optimal data and weeding out the unnecessary dump of data for companies who like their work organized. It also helps spot out anomalies, which further helps in processing the right data. Statistics helps you in powerful insights. Dashboards, charts, reports, and other data visualization types in the form of interactive and effective representations give much more powerful insights than plain data, and it also makes the data more readable and interesting. And finally, statistics help you in segmentation and optimization. Statistics segments the data according to different kinds of demographic and psychographic factors that affect its processing. It also optimizes the data in accordance with minimizing risk and maximizing outputs. Apart from all these factors, some of the statistical methods are also imperative approaches while analyzing complex data, which I will talk about them later. Now, it's time to take a look at different types of statistics. There are two main categories in statistics: descriptive and inferential. Descriptive statistics churns the data to provide a description of the population by relying on the characteristics of data providing parameters. For example, in a class, if we need to find information about the marks of some students in a test, in descriptive analysis, we note the marks of every student in the class. Then, we note the highest marks obtained by a student and the lowest marks, and finally the average of the class. On the other hand, inferential statistics makes predictions and assumptions regarding a large population by the trends prevalent in a sample taken from our dataset. For example, in the recent past, many clinical trials have been done for the coronavirus vaccine, and some people are being chosen at random as a sample size from the immense population of different geographical locations. But the important question is how we use these two types of statistics in order to analyze our data. Good question. About descriptive statistics, I should say whenever descriptive analysis is practiced, it is always done around a central measurement, which actually plays a huge role in determining the results. These central parameters are the mean, median, and mode. But let's throw some lights on them to see what they have for us. About the mean, I should say the measure of an average of all the values in a sample is called mean. For example, if we need to find the mean of marks obtained by the students of a class, we will take the sum of all marks and divide it by the total number of the students. About the median, I should say that the measure of the central value of the sample set is called median. For example, if we need to find the median of the marks obtained by the students of a class, we will arrange them in ascending or descending order of marks, and the value in the exact middle of the size taken will be considered median. And finally, About the mode, I should say the most recurrent value in a sample set is known as mode. For example, if we need to find the mode of the marks obtained by the students of a class, we will see the most recurring marks that most of the students have received, and that will become the mode of the class marks obtained. Now, it's time to see how we can get insights from inferential statistics. Inferential statistics is more prevalent in studying human nature and understanding the characteristics of the living. To analyze the trends of a general population, we take a random sample and study its properties. Then we test the findings, whether they comply with general population accurately or not, and then finally provide results with conclusive evidence. Statisticians use some concepts like hypothesis testing to formally check whether the hypothesis is accepted or rejected. Hypothesis testing is an inferential statistic technique used to determine whether the evidence stands tall in a data sample to infer that a certain condition complies with the entire population or not. And finally, to wrap up the video, let's see what we have learned so far, shall we? First, we saw some examples of the applications of statistics in real-world problems and figured out how helpful this science can be. Then we saw how statistics can help data scientists in many ways, like classification and prediction, optimization and segmentation, and creating probability distribution. After that, we learned about two major types of statistics, descriptive and inferential, and learned how these two can help us derive insights from data. And that's done. Congratulations! Now you know how we can use statistics to analyze our data, and in later videos I will talk about its definitions and formulas to learn practically how to analyze data with it. If you like this video, please hit that like button, and if you are interested in this type of topic, please consider subscribing to this channel. I hope this video helped you a lot, and until then, happy learning.